Next definition, left coset of H in G. Let H star, H comma star be a subgroup of G comma star. For any A element of G, the set AH defined by AH is equal to set of all A star H such that H belong to capital H is called the left coset of H in G determined by the element A element of G. So how do you define left coset of H? And here capital H is subgroup of capital G. H comma star is subgroup of G comma star. Now let us take an element from G, okay? For any element A in G. So for any element A in G we can define left coset, okay? For any element A in G we can define left coset, that is AH is equal to. So you take this A to the left of H, that is AH is equal to set of all A star H such that H element of capital H is called the left coset of H in G. Okay, AH is equal to set of all A star H such that H element of H. Okay, so this AH contains elements of the form A into H, A star H, okay, elements of the form A star H. So what about the small h? Small h should be taken from capital H. So you can fix this A and you can take H from capital H. So set of all these elements are called as left coset for this particular element A. Similarly, we can define right coset for any A element of G, okay, for any A element of the group G, and H is the subgroup, okay, H is subgroup of G. Right coset H A is equal to, okay, left coset, we took the left coset, just now I defined the left coset, right, AH, right, right coset is H into A is equal to H star A, set of all H star A, where H element of capital H, okay, where H is element of capital H. So this set is called as right coset, right coset. So now let us learn the theorem, Lagrange's theorem. The order of a subgroup of a finite group divides the order of the group. Important theorem. It is very important for the university exam. The order of a subgroup of a finite group divides the order of the group. Or if G is a finite group, order of H divides order of G for all subgroup H of G. So here you should understand the question. H is subgroup of G. Okay. So let me explain the theorem. G is a group. H is a subgroup of G. To prove order of H divides order of G. That is, you can write like this. Order of H divides. You can write divides like this. Okay. You should read it as divides. Order of H divides order of G. That means when you divide order of G by order of H, what do you mean by divides? Remainder should be 0, right? That is, so order of H. Order of H, you know what is, we have defined order of H in the previous video. So finding order of H and finding order of G, if you divide order of H by order of G, then we say it divides when the remainder is 0. Okay, so here is the proof. Let order of G is equal to n. Here n is finite. Okay, we assume order of G as n. Let G is equal to A1, A2, A3, etc. An. So why we take up to An means because order of G is n. There is only n elements in G. Okay, we have n elements in this group G. Therefore, we take A1, A2, A3 up to An. And one of the element is definitely the identity element, right? In a group contains identity element. So we assume A1 to be E. So A1 is equal to E, then A2, A3 up to An. And let H be a subgroup of G. We assume H to be the subgroup of G. Now let us consider the left coset. Okay, just now we have learned what is the left coset. Left coset E star H is equal to. So left coset means E star H, right? Just now we learned it is something AH. AH is a left coset and HA is the right coset. Here I am considering the left coset E star H. E star H is equal to E star small h, where small h is element of capital H. So you write a small h here which is missing, okay, like this you can write small h element of capital H. Now let me take the second element A2. For A2 also we can define left coset. A2 star H is equal to set of all A2 star H. So this is small h, there is a mistake, small h, make it a small h, where small h element of capital H. Similarly, an star H is equal to, this is left coset for element an star small h such that small h element of H. So it is like this, okay, left cosets, I have written that here, E star H, set of all E star small h, H belong to capital H, A1 star H, A1 star small h such that set of all H belong to H, etc. We can take A2 also, A3, etc. We have n elements in G, right? G contains n elements, that is E, this is A2 because E is A1. So let me write that. A1 is identity, okay? A2, A3, etc. An. N elements are there, A1 to An. So you can take A1, A2, An. So we define left coset for all the elements of G, okay? Left coset for all the elements of G, and it is defined like this. Okay, now I'll give you some explanation. That is, you consider the property, okay? We know that any two left coset are either identical or disjoint. Identical means same, or it will be different. Okay, disjoint means intersection is empty. Identical means they are same. Every element of the first coset is same as the second coset. So when you consider two cosets, so I have taken some cosets here. You see, coset of H. What are the cosets of H? Just now we learned. We take elements of G, right? Elements of G. G has E, A2, A3, etc. An. Okay, G, element of G are these elements, and for any element from G, you take E from G, you take A2 from G, you take An from G. We define left coset as E star H, A2 star H, An star H, and these are the left coset, right? Left coset for elements of G. Now, what is E star H? Suppose I consider H as, okay, H as, H is equal to H1, H2, H3, etc. Hk. Then what is E star H? We know E star H is set of all E star H. H belong to capital H. Okay, we know that H element of, you see, the small h is element of capital H. Now capital, small h element of capital H. Capital H has H1, H2, H3, Hk, etc. Hk. So we can write E star H1, E star H2 because H1, H2 element of capital H. So we take all the elements of capital H. All the elements of capital H, and E star capital H means E star small h1, E star small h2, E star small h3, etc. continues, etc. up to E star hk. Okay. Now what is A2 star H? When we come to the second case, A2 star H. A2 star H is A2 star H1, A2 star H2, A2 star H3, etc. A2 star Hk. A2 star Hk. Now what is An star H? An star H is A1 star, A1 star, An star H1, An star H2, etc. An star Hk. So now we can identify number of elements in H and number of elements in E star H will be same. Is it not? Number of elements in both these sets will be same. If I take, how many elements are in H? K elements, right? 1, 2, 3, etc. K elements. Order of H. Number of elements, or I write number of elements in H is K. What will be the number of elements in E star H? You see, H1, H2, etc. up to Hk. Number of elements is K. You take the second left coset. You take the second coset. 1, H1, 1, H2, 2, Hk, etc. up to Hk. Number of elements is k. You take An star H, An star H1, H2, An star Hk. Number of elements is k. Okay. How many elements are there in k? H1, H2, H3, Hk. Number of elements is k. So we write order of the coset is equal to order of H. Okay. Order of number of elements in E star H is equal to number of elements in H. O of E star H is O of H. Okay. So now order of E star H, number of elements in E star H is O of H. Order of A1 star H is also order of H, etc. It goes on, right? Order of AI, for it is generally I can write order of A star H is equal to order of H for all I. For all I, okay? For all I, or we can write for all AI. We take AI from G for every, this is read as for every AI element of G, for every AI element of G. For every AI element of G, order of AI star H is equal to order of H. So also union of all the left coset of G is equal to G, okay? So using this property, what is that? Union of all the left coset. Union of all the left coset of G is equal to G. So we can write G is equal to what is that? Union of all the left coset of G. What are the left coset of G? Just now we have taken left coset of G is A1 star H, A2 star H, etc. AK star H. Okay. We know any two left coset are either identical or disjoint. So now let us assume there are k distinct left coset. There are left coset, and let us assume there are k distinct left coset. Okay. So we can take E to AK. There are k distinct left cosets. So also now let me give some more explanation. We have the property union of all the distinct left coset of G is equal to G. Okay. Union of all the distinct left coset is equal to G. So therefore G is equal to, let us take union of the different left coset, that is A1 star H, union A2 star H, union etc. AK star H. Here there are k different left cosets. Okay. K distinct left cosets. So I take up to AK. Now order of G is equal to order of, so number of elements in G is same as number of elements in order of A1 star H plus order of A2 star H plus etc. plus order of AK star H, because by property, okay, union of distinct left coset of G is equal to G. So order is also equal. Now what is order of A1 star H? So just now we discussed order of coset is equal to order of H, because we take elements from H, okay. Number of elements in H depends. So order of this coset is equal to order of H. So we can write order of A1 star H is order of H, order of A2 star H is order of H, order of AK star is order of H. So we can take k times. How many times we can take this order of H? A1, A2, AK. So k times. So if you take k times, k into order of H. K into order of H. Now you bring this order of H to the denominator, we get a perfect number. Okay, we get an integer. So what about this? This is an integer number, right? Number of times, k times order of H. So we say order of H divides order of G. So therefore order of H divides order of G. So you divide something. 4 by 2 is 2, right? We say 2 divides 4 because the answer is 2 here. 2 divides 4. 6 by 3 is 2. 3 divides 6. Similarly, order of H divides order of G. So this is the proof here. Hence we have proved that order of the subgroup divides order of the group.